The word storm has many different meanings. Sometimes a storm is a mild summer shower. Sometimes a storm is a very heavy rain, often described as a downpour or cloudburst. Sometimes a storm is torrential rain and driving wind, a hurricane. Because storms affect all of us and can result in the loss of property and life, it is necessary for us to understand the causes of storms. The weatherman, the meteorologist, gathers information about storms and plots this information on weather maps. Storms are the result of a combination of three basic elements of weather. On this map, we'll illustrate the three basic elements of weather. Suppose a mass of cold air from the Arctic or northern Canada is moving southward across the United States. At the same time, a mass of warm air from the Gulf of Mexico is moving northward. The two air masses approach each other. The difference in temperature between the two air masses is one element that may bring about a storm. The cold air mass is dense and heavier than the surrounding air. It has greater pressure. The warm air mass is lighter than the surrounding air. It has less pressure. Difference in pressure between the two air masses is a second element that may bring about a storm. The colder, heavier air is dry, while the warmer, lighter air is more moist. The difference in the amount of moisture, or water vapor, that each air mass contains is a third element that may help to bring about a storm. Here is a warm air mass lying over the land. Storms often develop when a cold air mass collides with a warm air mass and forces it upward. When this happens, we say a cold front has developed. Along the front, a line of storm clouds may develop. These clouds, called cumulonimbus clouds, are usually an indication of an approaching thunderstorm. To understand how the elements of temperature, pressure, and moisture interact to produce a storm, let's follow the development of a single cloud. When air near the surface of the Earth becomes heated, the cooler air around it pushes it up. As the air moves upward, it is cooled. Some of the moisture, or water vapor, is cooled to a point where it condenses into the small droplets of water that form a cloud. At this stage, the temperature of the air within the cloud is warmer than that of the surrounding air. Within the cloud, the small droplets of water combine to form larger drops of rain. Within the growing cloud are accumulations of positive and negative electrical charges. These cause some lightning flashes within the cloud, or between the cloud and the Earth. At the same time, some of the water vapor is forced to a height called the freezing level, where the vapor changes to ice crystals. Some of these ice crystals are blown out of the top of the cloud. These ice crystals give thunderheads their peculiar anvil-top appearance. As the raindrops fall down through the center of the cloud, they cool the air in the center, causing violent downdrafts that pour out of the cloud, becoming strong gusts of wind along the ground. Next, there is a heavy fall of rain, or sometimes of hail. Although we've been looking at a single cloud, remember that a storm usually includes a number of clouds, extending a distance of perhaps several miles along a front. In a fully developed thunderstorm, the lightning, the wind, and the rain are the result of the interaction of temperature, pressure, and moisture. These same elements can also cause a far more violent kind of storm, a tornado. The funnel-shaped cloud is made up of rotating winds with speeds that may exceed 300 miles per hour. Tornadoes have been known to lay waste an area 1/4 of a mile wide and a 1/2 mile long in less than a minute. Within the funnel, extremely low pressure causes a tremendous updraft, which acts almost like a gigantic vacuum cleaner. The result is massive destruction. Buildings may be leveled, and sometimes heavy objects may be carried hundreds of feet through the air. Meteorologists do not fully understand the exact manner in which the three elements of temperature, pressure, and moisture combine to cause the tremendous forces within a tornado. Yet, with the help of instruments, such as radar, meteorologists are able to track violent storms. Because radar can scan a vast area, it is particularly useful in tracking another kind of violent storm, the hurricane. Hurricanes start to develop in much the same manner as thunderstorms, although they usually form over the oceans. A hurricane originates over the ocean in an extremely warm, moist air mass of low pressure. This air mass develops a circular motion. The rotating action forces the hot, moist air at the center of the low-pressure area to rise. The lifting action cools the air, causing the water vapor in the air to condense. The condensing action heats the surrounding air even more, causing cooler air to rush into the rising air mass. This increases the rate of condensation, and the rising action becomes even faster. Soon the hurricane is a giant rotating wheel, averaging 400 miles in diameter and over 10 miles high. On this radar screen, time-lapse photography shows the development of a hurricane. Notice the dark spot, called the eye of the hurricane. Notice, too, the rotation of the hurricane. Hurricanes move across the ocean toward land. As the hurricane approaches, violent winds develop, and there is a torrential rainfall. But as the eye of the hurricane passes over, there may be nearly an hour of relatively calm air and sunny skies. After the eye of the hurricane passes, the wind begins to blow again, this time from the opposite direction, for now the other side of the revolving hurricane is passing by. Once again, the wind may reach violent force. The destructive winds often reach a velocity of 150 miles an hour. Tremendous damage may result from the violent winds of hurricanes. The greatest loss of lives and property is usually the result of the flash floods and high tides that accompany hurricanes. We have seen how the three elements of temperature, pressure, and moisture interact to cause storms. We also saw three common types of storms: thunderstorms, tornadoes, and hurricanes. Now let's see two kinds of storms that are most directly the result of high winds. During dry weather, winds may cause dust storms. In a dust storm, great quantities of loose soil may be carried for miles. High winds blowing fallen snow are also responsible for the kind of storm we call a blizzard. So storms are an important phenomenon of weather. While meteorologists continue to learn more about the interrelationships among air temperature, pressure, and moisture, they are also using new tools, such as satellites, to help explore the Earth's atmosphere and to collect more information. Such information makes possible more accurate prediction of the formation and movement of storms.